Hello students, welcome you for the class of work part energy. What did we study in the last class? In the last class we have seen the complete numericals based on the first part of work part energy, that is your before semester examination. So from today we are starting on the second part of work power energy. What did we study in the first part? We completely studied what you mean by work, power, energy, and what is the SI unit, CGS unit, relationship between the measurement for the expression for what you mean by work, what is the expression for power, what are the SI and CGS units, the relationship between SI and CGS units, and also numericals based on a simple numericals based on the formula W is equals to Fs cos theta. Right. From today we are going to start with the second part of work power energy. What is the second part of work power energy? Is different forms of energy. This is the different forms of energy. See, already we have seen in our 8th standard based on the same lesson I myself taught you. It's a very simple chapter also. Now, in different forms of energy, first we have the topic of what you mean by mechanical energy and its forms. What you mean by mechanical energy and its forms. What is mechanical energy and its forms? You already know this. What you mean by mechanical energy? Let me define you again. The energy possessed by a body. The energy possessed by a body. Due to its state of rest. Due to its state of rest. State of rest or state of motion. Or state of motion. Motion is called what you mean by mechanical energy. What do you mean by mechanical energy? This is what we studied even in the case of our 8th standard. So what do you mean by mechanical energy? It's an energy possessed by what? Body. This is a key word. A body should be there. Otherwise, its meaning is waste. Okay? By a body due to its state of rest or state of motion is called as what you mean by mechanical energy. Wait, you already know this mechanical energy is broadly classified into two types. Is it not? Yes. This mechanical energy is broadly classified into two types. What is that? The first one is what we mean by potential energy. What we mean by potential energy. And the other one is what we mean by the second one. It is kinetic energy. Potential energy as well as kinetic energy. Right. So first let us discuss potential energy completely. What do you mean by potential energy at all? Now we need to remember one thing. See, the energy possessed by a body due to its state of rest. If it is state of rest, then it is called as what you mean by potential energy. If mechanical energy is in state of rest, then it is called as what you mean by potential energy. If this mechanical energy is in state of motion, if it is in state of motion, it is called as what you mean by kinetic energy. That is what the definition of mechanical energy is like. The energy possessed by a body due to its state of rest. If mechanical energy is in state of rest, it means that it is having what energy? Potential energy. If mechanical energy is in a state of motion, it is having what type of energy? It is kinetic energy. Both are derived from which energy? Mechanical energy. Mechanical energy is derived into potential and kinetic. When it will be potential and when it will be kinetic. The body, if it is in state of rest, it will come under potential energy. Means it is having a potential energy. If it is in state of motion, it is having what energy? Kinetic energy. And one more relation you need to remember, very important, that is total mechanical energy types of mechanical energy. So total mechanical energy of the system will always be equal to sum of potential plus kinetic. So that explains the loss of conservation of energy. Energy can either be created or be destroyed, but it can transfer from one form to another form. The same thing comes into picture in the case of total mechanical energy is equal to sum of potential plus kinetic. So I hope you have understood what is mechanical energy in its forms. Now we will study one by one slowly, because now when we study first potential energy, even then it comes in different types in that. When we study kinetic energy, even there is different types in that. So one by one we will do it slowly. Now first let me consider what we mean by potential energy. Okay? First let me consider what we mean by potential energy. See, remember this potential energy is denoted with the letter U. What it is? It is denoted with the letter capital U. Now let me define what is potential energy. The energy possessed by a body at rest. The energy possessed by a body at rest due to, this is very important definition, sir, due to its position or size and shape. Is called potential energy. Is called potential energy. Understand? See how I have defined the energy possessed by a body at rest. Already know state of rest is nothing but potential energy. The energy possessed by a body at rest due to its what? Due to its position or size and shape is called as what we mean by potential energy. So let me give some examples for this. Example of potential energy: water stored in a dam. Water stored in a dam. A warm watch. Stretched bow. What do you mean by stretched bow? These are the three examples I have taken to make you understand the potential energy better. So what it is, look at it. Water stored in a dam. It is in what? It is in a position. The water is stored in a dam. So it comes under what? Position. It is at rest, means it is in some position. Size and shape, change in size and shape. See, I owned a watch. When you own a watch, it is what? You are making it for a time limit. So that comes under shape. Even a stretched bow, what you are doing? You are stretching it, means you are making it come to other decision, like other size. That also comes under what you mean by shape. Shape and size. Understand? So based on these things, potential energy is also classified into two types. So what are those? Potential energy is classified into, again is being classified into two types. So first one is what we mean by gravitational potential energy, and the second one is known as elastic potential energy. Now gravitational potential energy is because of position, change in its position. Okay. So what about elastic potential energy? Change in its size and shape. Understand? So potential, it is at rest, no doubt. If it is change in size and shape, it comes under elastic potential energy. If it is change in its position, it comes under what you mean by gravitational potential energy. Now, let us go in detail what you mean by gravitational potential energy and what you mean by elastic potential energy. And very important, there is a derivation we need to derive for potential energy. The expression that is U is equals to mgh. Even I made it to do in 8th itself. If you remember 10th standard textbook, I used to take when you were in 8th, and we did all the derivation what is being required for 10th standard. Again, it will be like a recall to you. Now let us proceed with the types of gravitational potential energy and elastic potential energy. Now we have the two types of potential energy. What are those? Like gravitational potential energy and elastic potential energy. Now let us see in detail what you mean by gravitational potential energy and what is elastic potential energy. See, the potential energy, when you are writing a definition, be very careful. You should not skip any of the very important terms. Since gravitational potential energy is a type of potential energy, we need to carry that in a definition. Look, the potential energy possessed by the body due to the force of attraction of Earth is called its gravitational potential energy. Means, for example, you know that when you consider a situation, think this is the Earth. Whatever the body which is being present above the Earth, it is going to have a potential energy. Understand? Potential energy is maximum. Potential energy is maximum when it is away from the Earth. Potential energy is zero when it is on the Earth. Potential energy is what? Potential energy is zero on the Earth. In turn, kinetic energy is maximum. Kinetic energy is maximum where on Earth kinetic energy is zero above the Earth. This is what the concept we need to understand, and we already know it is in the 8th standard. Now, potential energy is maximum where above the Earth. If some body is above the Earth, what it will be doing? So obviously we know there is a gravitational force which is being present. It means Earth is keep on applying a force on this. Towards which side? It will be pulling towards downwards. Right? The gravitational force will be acting downwards. But still, if you want to make the body to stand here, look, now a chalk. If I just leave here, what happens? It comes back to the Earth. What is the reason? Because Earth is having gravitational force towards it. If I want to make this chalk to be at this position, what it is, I need to keep on holding it. When you keep on holding it, what you are doing? We are applying a work on it. Right? I am doing a work of holding it. Since I am doing a work, it is not able to fall. Means I am doing a work against the force of gravity. Already we have studied work done is equals to force into displacement. Now, if there was a pulley is doing some work, what happens if a pulley lifts it? He is doing a work against the force of gravity. When he just keep it on his head, he is making what energy? The work what he has done is stored in the form of potential energy. Now, just when you leave that a bag, it falls down. How did it fall down? How much of work you have done on it? It will fall in the form of kinetic energy. Understand? This is what the concept of what you mean by potential and kinetic. In which potential energy we have two types. What do you mean by potential energy? The energy possessed by body due in the state of rest itself, due to change in its position and change in exertion. Change in position comes under which energy? Gravitational potential energy. Look, there is a change in its position. When it is changed in position or it is above the Earth, it always comes under what you mean by gravitational potential energy. Understand? So the potential energy possessed by a body, with it's okay, you can take it by a body due to the force of attraction of Earth. Due to what? Force of attraction of Earth. On it is called what we mean by gravitational potential energy. So very two important notes I have taken. The gravitational potential of a body is zero. When they will ask you a question in ICSE, when the gravitational potential energy of a body is zero, when it is at infinity, that is C. If Earth is here, somewhere it is infinite place. If it is there, gravitational potential energy of the body is zero. How? Because there will be no gravitational energy till there exists. Gravitational energy of Earth applies to some extent. We all know that. We all have to, when the rocket is launching, we need to give it fuel only when it escapes from the Earth's atmosphere. Until that there is a gravitational force. After that, there is no gravitational force at all. It goes according to the trajectory directions. So, gravitational potential of a body is zero when it is at infinity, because the force of attraction of Earth on a body is then zero. There will be no force of attraction of Earth on a body if it is at infinite distance. The reason is there is no gravitational force which is being present at infinite place. Understand? They will ask you very important question, please. Next, as the distance of a body from the surface of the Earth increases, the force of attraction of Earth decreases and its gravitational potential energy increases. It's a very simple thing. When you are on Earth, your potential energy is what? Zero. When you keep on moving away from the Earth, your potential energy increases. That is, gravitational potential energy increases, and the Earth, whatever the force which is being put by Earth, that is gravitational force, what happens? Decreases. That is what in the case of rocket motion. When a rocket is launching, right? For example, you consider rocket works on Newton's third law of motion. Principle of rocket, you know that. When a rocket is launching, what happens? This gravitational force or potential energy increases and it is leaving from the Earth's surface. So that is what we explain. Surface of the Earth increases, the distance of a body from the Earth's surface increases, the force of attraction of Earth decreases. At some level it is. After that there is no gravitational attraction which is being happening on the body. So these two are the very important notes you need for the examination point of view and also for the understanding of the concept. So I hope you have understood what we mean by gravitational potential energy well. Now, apart from gravitational potential energy, we have given potential energy in the case of changing size and shape or deformed state. That is known as what we mean by elastic potential energy. Now, what is elastic potential energy? Now, the aim you need to write the potential energy possessed by a body in deformed state. What do you mean by deformed state? Changing state. That's all. See, now you have a bow and arrow. If you want to shoot an arrow, what you have to make the elastic part of the arrow? You need to take. So a bow, you want to stretch the bow. Means you are what you are doing. You are doing it, right? For example, if you have like this, you are stretching it. If you want to even shoot an arrow, is it not? It is getting deformed. Means whatever the power you are having on this stretching it, with the same power, what happens? The arrow goes. If you are using a less stretch, it goes less distance. If you are stretching it more, it is going to more distance. Means whatever the work, how much work we are doing on it, so much of energy is being converted into that. Means how much potential energy you are storing it, that will be making the kinetic energy also to get increased. Okay. In deformed state, due to change in its size and shape, there is change in its size and as well as shape, is called what we mean by elastic potential energy. Now let us see very important notes. And see, we have studied what is the concept of rigid body and non-rigid body in the case of force. I myself taught you. When we apply a force on a rigid body, there is no change in its size and shape. Because why? Rigid body is very hard. Right? Rigid body is very hard. But when you apply a force on a non-rigid body, what happens? There is both change in size and shape as well as there is causes a motion. That is what I told. Now when you take a bow and arrow, bow is an example of rigid body or non-rigid body. It is nothing but non-rigid body. This is non-rigid body. So each and every lesson is important because the knowledge of that lesson needed in this lesson also. It is not. Everywhere it is giving interrelated topics. So non-rigid body, it gets deformed due to change in its size and shape. See, if you take for example steel arrow, can you bend it? Why? It is a rigid body. So always we need to take what? Non-rigid body. So that its size and shape changes. Understand? When you take a spring, what happens? It acts like a deformed way. But when you take some other thing, can you do that? No. Right? So this is the first point. It's very important. We need to always choose what? Non-rigid point. Next we have, on removal of the force, it regains its original form due to the property of elasticity. Obviously, when you are stretching the arrow, right, bow, when you just leave the arrow, what happens? What happens to this elastic part? It comes back to the original position, right? So that property is known as what we mean by elasticity. You take a rubber band, you stretch, when you leave, what happens? It comes back to its old position, right? So that is the property of what you mean by elasticity. So usually in the gravitational elastic potential energy, we have a property of elasticity which is being keep on playing. You have a watch, a spring watch, you will wound up. Just if you remove, what happens? It comes back to its original position. Even that is a better example for elastic potential energy, as I have told before. So this is about what we mean by types of gravitational, or what do you mean by potential energy? That is gravitational potential energy, also elastic potential energy. Gravitational potential energy is completely on position. Position is on Earth or above the Earth. Above the Earth, it is having what we mean by gravitational potential energy. Elastic potential energy is related on what we mean by size and shape. Deformed size and shape gives you elastic potential energy, but no doubt both are the types of potential energy. Understand? So now we are going to the topic of derivation, like how to derive an expression for gravitational potential energy. That ends up today's class. From the next class, we are going to see about what we mean by kinetic energy and its types and its derivations. Now we have the derivation to derive for gravitational potential energy at a time. So that we need to get this expression U is equals to mgh. So now let me to derive that, let me explain you some concept. The gravitational potential energy at a height above the ground is measured by the amount of work done in lifting it from the ground to the height relates to the force of gravity. Means, see, think for example, it was an earth. It's an earth. There was a body which is being lying above the ground. Now what about its potential energy? Its potential energy is 0 above the ground. Right, sorry, on the ground. We know that. Now I will lift this body from here to, just I'm lifting it up. Now it had reached this place from here to here. Means what I am applying on that? I am doing some work in order to lift this body from here to here. Is it not? So it has some height h. The height which is being called as what you mean by h. And you are doing your work against the force of gravity. Right? Here what is the force when you are applying? Force is nothing but m into g. Why I have considered m into g? Because first of all this body has some mass. The force whatever you have been applying. G is the acceleration due to gravity. When you are taking it, Earth in turn will be trying to pull the body. Just if you leave, what happens? It comes back. But still if it is there, now it is going to have what? It is above the ground, so it is possessing what we mean by gravitational potential energy. That how much gravitational potential energy it has. To find out that, we can find out by using what? The work done in lifting it from the ground. If we calculate the work done, it's like knowing that how much is the gravitational potential energy of a body above the ground. Understand? So to derive that, let me consider. See, always a diagram is must. If you write in a diagram, it's well done, must. Now, before starting of the derivation, we need to write a write-up, whatever you are considering. Like I have told you this before only. Let a body of mass m moving from ground to a height, body of mass to a height with a force that is potential, that is displacement which is being happening. That is S is nothing but H. So the work done. So the work done to move the body. The work done to move the body. The work done to move the body from ground to a height is given by expression, that is work done is equals to force into displacement. Right. Now work done is W. Force. What is the force I have taken here? Force is nothing but mass into gravity. So it is mg. So displacement is usually S. The displacement is happening from here to here. That displacement is taken as what? Height, h. Therefore it is h. So we have W is equals to 1g h. Since the work which has been done is stored in the form of what? Potential energy. The work whatever you are doing from here to here is stored in the form of potential energy. What potential energy? Gravitational potential energy. Hence, you can take, hence the work done. Hence the work done is stored. Is stored in the form of work done is stored in the form of gravitational potential energy. Gravitational potential energy is denoted with the letter U. Therefore, U is equals to mg. This is the expression for gravitational potential energy. U is equals to mg. You need to give a write-up, you need to draw a diagram, you can write it like that. Understand? It's a very, very important. This time they have reduced the syllabus, remember. So they may have a chance of asking for 4 marks. What is the derivation for potential energy? Gravitational potential energy, then you need to do in this. Understand? So we have given derivation for kinetic energy too. And what is the relationship between kinetic energy and momentum? There are many derivations that is going to come up. Understand? And when numerical is asked, when some numerical are asked, you need to be very careful. See the situation. Note, you can give it as note. Okay, here. See, there is a situation I am giving you. Body was here. Understand? Now, this is an earth. If a body is moving from earth, what happens? When it is moving up, its gravitational potential energy obviously increases. When it is coming down, gravitational potential energy decreases. Think that a body has moved till here first. Think this is, for example, h1, height h1. Then from here, again it has moved to here. This is what we mean by h2. Okay. Here, how can we calculate the gravitational potential energy? That is, this is initial and this is final. Since it will keep on increasing, whenever they give like this, whenever you give the numericals, it will be like that. So when gravitational potential energy increases, they give that like they have mg. If you want to find the gravitational potential energy, you have two heights. So mg h2 minus mg h1. That interval you can write even as taking common mg and mg h2 minus h1. Remember, this is when gravitational potential energy is increases, that is, it is moving up. Understand? Now, for example, make this change h1 minus h2. It is coming down. Now the body is keep on coming down. When it is coming down, what happens? Gravitational potential energy, if it is coming down, it decreases. So we have gravitational potential energy decreases, and gravitational potential energy Here it was like we can take even U is equals to final potential energy minus initial potential energy. Here it is initial potential energy minus final potential energy, that is mg h1 minus mg h2, that gives you mg h1 minus h2. That will be written as, for example, U is equals to initial potential energy minus final potential energy. This is very important. They have given in your textbook even, just go through that. This is very important for the numericals when they ask, because they won't ask only simple numerical on this formula. There will be some twist. Since it has been an ICSE, obviously there is some twist. It is not a twist when you understood the concept clearly. So this is what the complete concept of potential energy, its types and derivation. Okay. From the next class, what we will do that we will be going on discussing on what we mean by kinetic energy and its types and its derivations. So I hope you have followed this concept. And if you have any doubts,